Hey guys, Mr. Myas is here, and today this is the final video for Calculus AB this is lesson 9.7. So we're going to look at some final integration techniques. This is when some of these integration techniques get a little tricky. So I'm just going to go over some tricks, some things you might need to know for the AP exam. So here we go. So let's suppose we're doing something like this, and sometimes we might want to add or subtract some terms from the numerator, or multiply both the numerator and denominator by some same common factor. Basically, if we're multiplying the numerator and denominator by the same thing, then we're just pretty much multiplying by 1. If we're going to add, then subtract the numerator by something, then we're basically just adding 0, which is okay. So we're not changing the function inside numerically. We're just changing it a little bit so that we can do the integration. So let's take a look at a couple of examples of these. So here we go. We've got this one, and by itself, if I made the bottom u, and then I try to do u prime, then we're missing a plus 2 there. So if I had a plus 2, I could use this as u, but I don't have a plus 2. So what I'm going to have to do is I'm going to plus 2 and then minus 2. So if I plus 2 and minus 2, then I'm just going to group these guys. And again, if I add 2 and subtract 2, then I'm really just making 0, right? So I'm going to group this, and I'm going to change this to 2x plus 2, so that's the first group, over x squared plus 2x plus 1. And I know that now the denominator, u primes to 2x plus 2, which is what we have on top, which is going to make this a hook. Minus 2 over x squared plus 2x plus 1 dx. All right. And then for this side over here, what I'm going to do is I'm going to change this to x plus 1 squared. So I'm going to factor it. Okay, so then, now that I got that, now I could do the integration. So I can do the integral for this one because I've got a hook here. And I'm going to have ln of x squared plus 2x plus 1 plus, all right, so this right here, this is just 2 times x plus 1 to the negative 2. So I'm going to have, well, it's actually, when I integrate this, I'm going to have minus, and then it's going to be x plus 1 2 times x to the negative 1 divided by negative 1, which is really going to make a negative and a negative positive. So I'm going to have plus 2 x plus 1 to the negative 1 plus c. All right, so that's an example of adding and subtracting the same value on the numerator. Let's take a look at multiplying and dividing the same thing on the numerator and the denominator. So what I could do here is, if I try to make u e to the x plus 1, u prime is e to the x, which I don't have an e to the x here, right? So that's not gonna help me much. So what I can try to do is I could try to do a few things here. Let's see. Let's try 2 things here. Let's try the first method, adding an e to the x and subtracting an e to the x. All right, so let's try that. So if I add an e to the x and subtract an e to the x, similar to what I did before, then notice here, e to the x plus 1, e to the x plus 1, right? That's the same thing. So I'm going to get, I'm going to split this up, 1 plus e to the x over e to the x plus 1, which is the same thing. It's just going to make that 1 in just a second. E to the x over e to the x plus 1. So this is just going to be the integral of 1 dx minus, now in this case, what I could do is I could say u is e to the x right here, and then u prime is e to the x, so that makes this a hook. So I really got something like 1 over u plus 1, which I can integrate. That's going to be a natural log. So I'm going to end up with natural log, oops, minus e dx over e dx plus 1. So I'm going to end up with x minus natural log of e dx plus 1 plus c. All right, so that's one way of doing it, by adding and subtracting e to the x from the top. The other way is by multiplying e to the negative x over e to the negative x. So we're really multiplying by 1. So if I do that, I'm going to have e to the negative x on top. E to the negative x times e to the x is just 1, plus e to the negative x dx. So now I could say u is e to the negative x, and u prime is going to be negative e to the negative x, which is what I kind of have. My computer's going crazy here. Right? I kind of have that. I have this. But I need a negative one here and a negative outside. So I'm going to put those in for my hook. Come on, man. So I'm going to have a 1 over u. Ooh, it just does not want to stay there. I'm going to have a 1 over 1 plus u form. So that's going to be an ln. So I'm going to have negative ln of 1 plus e to the negative x plus c. And believe it or not, they do end up being the same thing. Notice there's a negative here and there, but they're going to give you the same thing. Okay, so those are examples of something we could do. Let's take a look at some other things. All right, so sometimes we have a trig identities here that we have to deal with. So sometimes we have to deal with trig identities. The most common substitution trig identities that we'll need is the tangent squared x equals secant squared minus 1, or the cotangent squared is cosecant squared minus 1. So let me show you an example here. Let's suppose I have to integrate this. Now I don't have an integral of tangent squared. I don't have an integral of cotangent squared if I split this up. But I do have an integral of secant squared, because the antiderivative of secant squared is tangent. Right? So because the derivative of tangent is secant squared. So what I'm going to do is I'm going to replace tangent squared with secant squared minus 1. And then I'm going to replace cotangent squared with cosecant squared minus 1. Right, so I do a substitution. Then I know that the antiderivative of secant squared is tangent squared. Now I've got a number in the middle here, so I need a 2 here. I need a 2 here and a 1/2 here. And I need a 3 here. And when I do the integral here, I'm going to need a 1/3. Okay? Okay, so I'm going to end up with 1/2. The antiderivative of secant squared is tangent squared. The antiderivative of 1 is x. The antiderivative of cosecant squared is negative cotangent squared. And the antiderivative of negative 1 is negative x plus c. All right, so that's how we use a trig identity. Could happen. Let's take a look at something else. Again, these are just a bunch of ones that are kind of tricky, things that you might see that you kind of need to use a little trick for. So sometimes we end up with something that we won't be able to deal with an absolute value. So for instance, let's say we want the absolute value from -3 to 5, the integral of the absolute value of this curve. Now we can't really do this all at once. So what we're going to do is split it up. And I'm going to take, okay, so we want the absolute value. So that means we want this shaded area. We want the bottom shaded area, but really we want it up top because we don't want it to be negative. We're going to add it, so we're going to do up here, right? And then we want this right here. That's what we want to do. So here's what we're going to do to integrate this. What we're actually going to do is we're going to integrate from -3 to -2 x squared minus x minus 6. And then we're not going to add it, we're going to subtract it. Subtract from -2 to 3 of x squared minus x minus 6, because this area right here, this integral is really, let me do this in blue. This integral right here is really down here. But I want the area that's up top, so I'm going to put a negative, and that'll take care of that. And then I'm going to add that to the integral from 3 to 5 of x squared minus x minus 6. All right, so this is the setup. Oops, I forgot my dx's. Don't forget your dx's. This is the setup for finding the shaded area in red. All right, so we got to split it up. All right, let's take a look at some other examples here of some other stuff that you might need. So in this course, we deal with the most common forms of integration. If you can't see what the common form of integration is, sometimes we got to deal with some algebra to do it. But our job here is to try to practice fitting the integrands into the basic formulas that you will memorize or that you have memorized, okay? So we're trying to get into the basic formulas. The basic formulas are reverse chain rule, power rule, the tangent, the arctangent and arc sine, and the natural log. So we're trying to get it in there. So let's take a look at a couple of them that we might be able to deal with. So let's integrate this big guy. Oh my gosh, look at all of this stuff. So I could tell you the first move that we always do when we have a monomial in the bottom is we separate the monomial. We split it up into the two parts right there. So that's the first move. So the first move we're going to do is this. Oops, minus. All right, the first move we split it up, and then we have to decide if we could simplify things. I think we could simplify this side right here. This side is not simplifiable. I don't even think that's a real word. It could be, but I'm not gonna. Okay, we'll bring this up to e to the negative 3x, right? Because in the denominator. And this is going to come up as e to the negative 2x because we're going to subtract the powers. Okay, and now it's actually something manageable. So whenever we see a sign and we have a bunch of stuff inside the sign, like there's just weird stuff, usually that weird stuff is going to be our u. And this seems to work out because u prime is going to be negative 3 e to the negative 3x, right, using the chain rule. So we have part of that here. We just need the negative 3, so I'm going to put the negative 3 in here and put a negative 1/3 out here. This one's an easy guy because I need a negative 2 here and a negative 1/2. So a negative and a negative make a positive, so let's just change it to a positive. Okay. All right, now we can integrate. So let's go and integrate this bad boy. So I'm going to have negative 1/3. The antiderivative of sine, because we're really just dealing with sine u, the antiderivative of sine is negative cosine. So it's going to make this a positive. Oops. Plus 1/2. This is a hook. Okay, this was a hook. The antiderivative of e is just e plus c. Okay, boom, got it. All right, so sometimes we just gotta get it to a form that we know. Okay, we've got a bunch of stuff here, a bunch of stuff in a squared. Whenever we have a bunch of stuff that's not just a polynomial, this stuff is really going to be the u. All right, so what's u prime? Well, ln of that is 1 over sine times the derivative of the inside, which is cosine. Well, look at that, cosine over sine. That's right here, cosine over sine. So we already have a hook. And you know what, I want to do that in green so you don't confuse what I'm doing. Okay, this is my hook. This is already there. So it's already a hook. So we're really just dealing with u squared, right? And the antiderivative of u squared is 2u. I'm sorry, not 2u. U cubed over 3. Okay, so here's what we got. Here's our answer. Our answer is going to be ln of sine x cubed over 3 plus c. That's it. Okay? All right. And one last thing to remember before I cut off this video, and I know it's been a long one here, but one more thing is that if you have a integral that has radicals in it, so it's a square root, usually in the denominator, and you can't fit it into any one of those things, so you don't have like an x squared in there, you know, because we know that that would probably be an arc sine. It's just an x, like this one. Then we're going to want to use u substitution. That's our last resort, our methods of last resort. So we're going to do that. So we're going to usually make u whatever's inside the square root. Okay, and so then du is going to be equal to dx. And x is going to be equal to u minus 1. All right, I just subtracted 1 there. Then I'm going to make my substitution. All right, so my substitution, my x was u minus 1. So u minus 1 plus 2 over square root of u, and dx was du, so I'm just going to put du there. All right, so now I'm going to get u plus 1 over square root of u, and square root of u is u to the 1/2. And I have a monomial now, so I'm going to split that bad boy up. So I'm going to have u over u to the 1/2, which is going to end up being u to the 1/2, plus 1 over u to the 1/2, which is u to the negative 1/2, which is going to get me u to the 3/2 over 3/2, plus u to the 1/2 over 1/2, plus c. And then I make my substitution back. So u was x plus 1, 2 times x plus 1 to the 1/2 plus c. All right? So again, method of last resort, if you have a radicand in there, a radical square root, you're going to go with u substitution. All right, that's all I got for you guys. That was it for AB Calculus. Good luck on your review, and good luck on the AP exam. We'll see you soon. This is Mr. Maestas, and catch you down the road. Bye, guys. Oh, don't forget to subscribe. You might need me later. Ha! Later. Bye.